what is meant by ratios, what are few properties related to ratios, and then towards the end part we'll do few of the questions that are related to ratios. Now let's just start with the idea. So what exactly is ratios? So for that, let's take an example. So suppose we have a vessel, and that vessel has, let's say, 24 liters of milk and 60 liters of water, for example. Now, if given this data, and if they ask us what is the ratio of milk and water in this particular vessel, so of course, if we find that out, then the ratio becomes 2 is to 5, because 24 and 60, if you reduce them further, uh, they both are divisible completely by 12. So 12 twos are 24, 12 fives are 60. So you get the answer as 2 is to 5, the ratio of milk and water. Now, also, when we say the ratio of milk and water is 2 and 5, it also means something very important, which means that the value of milk can be any multiple of 2, and the value of water can be any multiple of 5. So for example, the original numbers were not 2 and 5, they were 24 liters and 60 liters, which is a multiple of 2 and a multiple of 5 for that matter. So it could have been 4 liters and 10 liters also, it could have been 6 liters and 15 liters also. All of this will come down to the same thing, which will be 2 is to 5. So ratios means need not to be the same number. It simply means any multiple of 2 and 5 will do the job for you. So that's a one thing. Secondly, once you know ratios, you need to immediately find out the fractions also. Now, again, what do we mean by fractions? So, fraction is out of total value, how much is that particular component. So, for example, when we say the ratio of milk and water is 2 is to 5, it means milk is 2 parts and water is 5 parts, which means there is a total 7 parts of mixture that is present in the vessel. Now, if I want to find out the fraction of milk, it becomes 2 by 7, and the fraction of water becomes 5 by 7. So, out of 7 parts, 5 parts is water and 2 parts is milk. That is what the interpretation is about when we say the ratio is 2 is to 5, basically. So, that's a very initial idea when it comes to ratios, basically. Now, if we move further, let's say the properties of ratio. The first one is this, which is a by 7 is equal to b by 5 is equal to c by 4. And obviously, we want to find out the ratio of a is to b is to c. So, what can be the values of ABC so that all these numbers are equal? So, in such scenarios, the best type of thought process is substitute the values of denominator only in the place of the numerator. So, for example, what is that supposed to mean? If we substitute a as 7, then that first number becomes 7 by 7, which is 1. If we substitute b as 5, then it again becomes 5 by 5, which is 1. And if we substitute c as 4, then again it becomes 4 by 4, which is again 1, for example. And you'll realize the ratio of a is to b is to c is also 7 is to 5 is to 4, because these numbers are not further reduced anymore, basically. So the answer remains the same. Now, for all we know, we could have substituted a as 14. So this would have become 2. We would have substituted b as 10. So this again could have become 2. And we could have substituted c as 8. So this again could have become 2, for example. And again, they all are equal if you see that ways. But when we find out the ratio of A is to B is to C, the values are 14, 10, and 8. And because it is ratios, so they are supposed to be further reduced again, and we would have gotten the same answer really, which is 754. So, the few things that you need to understand from here is that the ratios can be either a simple topic or a difficult topic to understand if you're not comfortable with numbers. So you can manipulate numbers a lot if you are good with ratios, and that is how you can use it to your advantage to make things easy when things are looking difficult in terms of numbers, in terms of calculations. So moving on, This was the first property. The second property, which says the ratios have been given and they have been given in fractions, for example. And we still want to do the same thing. We want to find out the ratio of A, B, C. Now, here, what you need to understand very clearly, that is, whenever you are dealing with numbers like these and you want to find out the actual ratio without the fractions, that is, convert them to proper numbers basically. So in that regards, the process is very simple. The process is you have to multiply every number with the LCM of the denominators. Now that means we have to find out the common multiple of the denominators, that is 754, which turns out to be 140. So this means what we are supposed to do now is multiply every number by 140, for example. And if you multiply every number, each of these numbers by 140, we'll get the answer. So the first number is 1 by 7. If we multiply 1 by 7 by 40, obviously we get 40 divided by 7, which is 20. Then if you do it by 1 by 5, this gives you 28. And if you do it by 4, then this gives you 35 as the number. So that means the ratio of A is to B is to C is going to be 20 is to 28 is to 35. And you say either 1 by 7, 1 by 5, 1 by 4, or you say 20 is to 28 is to 35. Both are same. It's just that it is not a standard practice to keep ratios in fractions. So we will convert them to proper numbers. Then the next part, the third property which comes to ratios is something like this, where 3, 4 numbers are equal to each other. Now, in this regards, what we should be ideally doing is let all of these numbers be also equal to some constant number, let's suppose k, for example, which means now individually every number is equal to k for that matter. So that means we can simply say we can simply say 7a is equal to k. So if I want to find out the value of a, it becomes k by 7. Similarly, 5 is equal to k, so the value of b becomes k by 5. And we want to take the ratios of ABC. So obviously the ratios of ABC will be this, k by 7, k by 5, and k by 4. Now after this, what we can do is we can take common k from all the numerators. If we do that, what we will be left inside the bracket is 1 by 7 is to 1 by 5 is to 1 by 4. And if you remember, just now a few moments ago we had simplified that by multiplying each number with the LCM of the denominator. So we end up getting the same answer basically. So 7a is equal to 5 is equal to 4c is also going to be 20 is to 28 is to 35. And this is how you can find it out basically. So this is the way to do that. Now let's look at the next property, which is this, where A is to B is given and B is to C is given, and we have to find out the value of A, B, C, all three of them combined together. Now how do we do that? So normally in such cases, what happens is whatever is the common multiple, you have to make it equal. You have to make it same basically. So the idea here is B is the common multiple here because A is to B and B is to C. So we have to make B equal. Now, one of the B is 5 and the other one is 4. So we have to make them equal. That means we have to take the LCM. So 5 and 4 ka LCM is again 20. Now again, think about this. To make this be 20, the first one, you have to multiply this thing by 4. That means the partner should also be multiplied by 4. That is A. So 3 4s it becomes 12. The second B is 4. To make it 20, we have to multiply this by 5. So we'll have to also multiply C by 5 because their ratio should not be hampered. Their ratio should be kept the same, which is 4 is to 9 for that matter. So when we do that, we end up getting the answer. So both the B's becomes equal, that is 20, but the partners, the respective partners changes. So for example, A becomes 12, 3 4s are, and B becomes 9 5s are, which is 45. So the value A is to B is to C, the final ratio of all three of them combined together becomes 12 is to 20 is to 45. And this is how we can find it out. So always remember, whenever such things are given, make sure you are making the common part equal and the respective partners will automatically change. Moving on, the next part is something called as proportion. There are two types of proportion. One is normal proportion, one is continued proportion. So for normal proportion, this should be the ratio, that is A by B is equal to C by D is equal to E by F. And if that ratio is matched, we can say that all these numbers are in proportion. Then for continued proportion, as the name only suggests, one number should be in continuation with the other numbers. Hence, we are going to do that. So A by B is equal to B by C is equal to C by D. So one of the numbers is in continuation from the previous term. So if that ratio is matched, then the numbers are said to be in continued proportion. The next part is few more properties of ratios. So let's take one of them, that is A by B is equal to C by D is equal to E by F. And let's say if we apply the property, the first property is something called as invertendo. So if you apply invertendo simply means that we are supposed to inverse the ratios. So A by B becomes B by A, C by D becomes D by C, and of course F by E becomes E by F becomes F by E, for example. The second property is something called as alternando. Now in the alternando, what we are gonna do is we are gonna take alternate terms and we are gonna simply swap the numerators and the denominators for that matter. So for example, when we do it for A by B and C by D, if we swap B and C ka position, we get A by C and B by D, for example. Then Then for the second and the third term, we get C by E upon D by F. And for the first and the last term, we get A by E upon B by F, basically. So this is something that is called as property of alternando, which is considering alternate terms and swapping their numerators and denominators. The third property is something called as componendo. Now componendo mein we have to add the denominator in the numerator. So we get a by b upon b, then we get c by d upon d, and then we get e by f upon f by applying componendo. Then when we do, let's say, dividendo, so for dividendo, what will happen is we will subtract the denominator from numerator. So we'll get a minus b upon b, we'll get c minus d upon d, and we'll get e minus f upon f, which is the property of dividendo. And lastly, componendo dividendo together. So when we do that, we'll end up getting in the numerator, we'll add the terms, in the denominator, we'll subtract the terms. So we'll get a plus b upon a minus b, c plus d upon c minus d, and e plus f upon e minus f if we apply componendo dividendo together, basically. So these are the 4 or 5 properties again that you will have to remember when it comes to the ratios part, basically. Then the next property is something called as property of equal ratios. So let's take one ratio again. A by b is equal to c by d is equal to e by f, and this is equal to r, for example. Now, if we apply the property of equal ratio here, what we need to do is we need to consider two at a time and simply add their numerators and denominators. So we consider the first two numbers, we get a plus c upon b plus d. If we consider the second and the third, we get b plus c plus e upon d plus f. If we consider first and the third, we get a plus e upon b plus f for that matter. Now, after the two numbers are done, what we will also have to do is consider all of them together. So if we consider all of them together, so what we will end up getting is all three numerators should be added and all three denominators should also be added. So if we add all the three numerators, we'll get a plus c plus e, and if we add all the three denominators, we'll get b plus d plus f. And the best part is all of them will still be equal to the same number, that is r, and hence it is called as property of equal ratios, basically. So these are the few initial basic properties that we should be aware of when it comes to the ratios part. I hope you all are understanding. Moving on, the next part is something called as direct and inverse variation. When it comes to direct variation, it simply means that things are directly proportional to each other. And what is meant by directly proportional to each other is that if one value increases, the other also increases, and if one value decreases, the other also decreases. That is meant by direct variation. So that's the very simple and the basic idea. Now, the main part that you have to remember is the graph. So graph is obviously going to be a linear graph because it's a straight line, because one value, if you keep on increasing the value on x-axis, the value on y-axis keeps on increasing, and vice versa. Most important thing again will be is a formula which is related to the question solving, and that formula is y1 upon x1 is equal to y2 upon x2. So out of the four things, three things will be mostly given in the question, and one of the things, unknown things, will be supposed to be found out, will be supposed to be calculated by using this particular formula, and which is what you need to remember basically when it comes to direct variation. And mostly questions will also be in that manner where it is mentioned that these two things are directly proportional to each other. That's how you understand you're supposed to use this concept and the formula. And similar kind of thought process is for inverse variation. So whenever we talk about inverse variation, it is again going to be inversely proportional, which means if we increase one value, the other decreases and vice versa. Similar kind of story. The graph is a curve here which normally touches x-axis at 0, and the most important thing will be the formula. So formula in this case becomes y1 into x1 is equal to y2 into x2. Similar kind of story or thought process in the sense that out of 4, 3 will be given in the question as the values. One unknown fourth value will be calculated using this formula. And also the relationship will be probably mentioned in the question, which says these two things are inversely proportional to each other. So from there you understand that you are supposed to use this formula, and you are supposed to uh, apply and solve and get your final answer. The next part will be now, since we are done with the questions, which will be solving of the questions using whatever we have learned so far. So here is the first one. I would request you all to pause this and give it a go and then see the solution. So here, a lot of the people make the same mistake, that one question or one similar concept that we had seen in the earlier part. But here, this is something that is not asked basically. So you should not be making the common things equal. Otherwise, you will go crazy, literally, because the numbers will become bigger and bigger when you keep taking the LCM. So for in the first instance only, 6 and 8 ka LCM is 48, which is then 48 and 7 and 16 ka LCM and so on and so forth. So that becoming more and more bad in terms of calculation. But here they have not asked us this, but they have asked us rather this. Now you have to understand one thing. How do we get this? So to get this, what you should be able to realize by looking at the expression, that is, since you have been given all the separate numbers, all the separate values, for example. So we can say if we multiply all these numbers with each other, we'll get what we are looking at, which is A upon E. So for example, this is what is the idea. So if we simply multiply all these numbers with each other, the expressions at least, so what will happen is, at least on paper, this B and B gets cancelled because they both are in numerator denominator and they are multiplied. Then these two are gonna get cancelled and these two are gonna get cancelled, and you will be left with only what you are looking at, which is A is to E. And that is exactly what we are also supposed to do here. So we have the values. Let's substitute them. Let's calculate them. A upon B is 5 by 8. B upon C is 6 by 7. C upon D is 16 by 15. And D upon E is 21 by 20. Let's do the calculation. So 8 2s are 16. 7 3s are 21. Then 5 3s are 15. 3 and 3 goes off. Then 10s are 20. So 6 by 10, which can be further reduced by 2, which should give you, I think, 3 by 5 is the answer, which is A is to E ka answer. When we simply multiply these numbers with each other. Yes, it is it is 3 is to 5, for example. So this is how you can calculate the first question. So the idea here is that what is the question and what is the method to solve that question, because the same method will not be applicable because the question is different. So the method or the thought process should also be different in this regards basically. So that is what you need to understand here. So this was your first question. Let's look at the second one, which says the ratio of 2a minus b is to 2b minus c is to 2c minus a is given as 3, 4, 5, and a plus b plus c is 24. Then what is the value of 2a plus b minus c, for example? So how do we do this? So very interesting is the first part is itself the most important part, which is you have to add all the three expressions. So you have to add all the three brackets, for example. So when we add all the three brackets, what we will end up getting is, so 2a minus a is a, 2b minus b is b, and 2c minus c is c. So we get a plus b plus c. And since we have added the numbers, the brackets, the expressions, I mean, we should also add the numbers. So 3, 4, 5 were the numbers, which is supposed to be 12. 3 plus 4 plus 5. And if you remember, in our data, a plus b plus c is given as 24, for example. So what you need to understand here is, so going from our system to their system, what is the uh, multiplying factor? So obviously it is doubling of the numbers, because 12 is 24. Ours is 12, theirs is 24, same number. So that means the numbers have been doubled here. So same thing should be applied to the other numbers also, that they all should be ideally doubled. And hence the values of 3, 4, 5 are not ideally 3, 4, 5, they are 6, 8 and 10 for that matter. Now, this is the initial part of the calculation. What we need to understand is what we are looking to find out. So what we are looking to find out is this, which is 2a plus b minus c, for example. Now the first thing you should realize is, how do you arrive at this particular expression? So clearly what you will have to do is, you'll have to add the first two brackets. So if we add the first two brackets, these are the values. So if we add them, this becomes b. So we get 2a plus b minus c, the value that we are looking at. And this value means the addition of the first two brackets. And the first two brackets are 6 and 8. So if we add 6 and 8, we end up getting 14 as the answer, basically. So for question number 2, answer is option 3, which is 14. And this is how you can solve that particular question. The idea here is that, which you need to remember, which you need to understand. The first step was the most important step. Question number 3. These expressions are given and then R cannot take any value except. So clearly when you see something like this, the first immediate thought process that should be there in your mind is something similar that we had learned, which is property of equal ratios. We have to apply that. So if we apply that here, what we will end up doing is, we'll add all the three numerators and we'll add all the three denominators. So if we add all the three numerators, we get a plus b plus c. If we add all the three denominators, we end up getting 2a plus 2b plus c, which we can take 2 common. Now here comes the silliest of errors that a lot of people make, and this, let this question be an example that you will keep remembering in future when you are doing this similar thought process. So after this, obviously, you probably are thinking in the right direction also, that a plus b plus c from both numerator and denominator should be cancelled out, and we get the value of r is 1 by 2, which is r. What happens is, we need to understand some background about this, in the sense that whenever we cancel something from both LHS and RHS, what is the operation that we actually perform? So we divide by the same number on both the side, and hence we can cancel it out basically. But here, unfortunately, the value of a plus b plus c that we are cancelling from both numerator and denominator. So here we should also be aware about the fact that whether it is 0 or whether it is not 0. The reason being very simple. If it is 0, unfortunately, then we cannot divide by 0, because then that means the value will be infinite, because we cannot divide by a 0. But if it is not 0, any other random number which is non-zero, positive, negative, doesn't matter, you can blindly cancel it out. And if you cancel it out, obviously you get the value of r as half, which most of would have guessed by now and would have figured out also. But here comes the twist. Unfortunately, since we do not have any clarity about a plus b plus c, it can be 0 also. And if it is 0, then that means we cannot cancel it out. And if we cannot cancel it out, then we will not be able to get r as 1 by 2. So what we need to do now after this is that we need to start doing some other calculation, and we need to start substituting the values or finding out the values of maybe a plus b or b plus c, etc., etc. So from here, the same equation a plus b plus c is 0. If I want to find out the value of a plus b, I hope you understand, it becomes minus c. Similarly, if I want to find out b plus c, it becomes minus a, and so on and so forth, right? And what we can do is we can substitute those values back in the original expression in the place of b plus c. As you can see, b plus c is a minus a, sorry, a plus b is minus c, and so on and so forth. And what then happens is these numbers will get cancelled out, because numerator denominator they are same, a b b c c, and r has another value which is minus 1. So point is that r will take two numbers, r will take two values. One is half and one is minus 1. So the correct answer is answer option 3. And what does this means for you is, if at all in future you are trying to cancel something from both numerator and denominator or both LHS and RHS, you got to make sure that it is not 0, because only then you can cancel it out. Because unfortunately, if it is 0, you will not be able to cancel it out and you will be stuck. So you'll have to think something like this, the way that we have thought here. So if there is no clarity, you will have to by default assume two scenarios and go forward. You cannot just simply assume that it is not 0 and just cancel it out. The problem is we don't think like that, but we need to think like that. That's the whole uh, learning from such type of questions. Very fundamental ideas, but very critical to apply them when we are doing the calculation as a checkpoint, so that we don't make that mistake. So that's your third question. Let's look at the next one, the fourth one. These are like classic ratio questions. So let's read that and then we'll try to solve it also. So this says there is a treasure chest which contains some 1 rupee coins, some 50 paise coins, and some 25 paise coins in the ratio 4 is to 6 is to 8 respectively. And the total value of the coins in the chest is 675 rupees. Then how many 50 paise coins are there? Now, what happens here is, lot many times in this particular example, people end up making a very silly error and they end up getting a wrong answer. And I'll also tell you how that happens and what can be done to avoid that, or what is the process to do that. So when we say the number of coins ka ratio is given 468, it simply means that any any number or any multiple of 4 6 and 8 is okay basically. So it need not to be 468, but any multiple of 468 is okay. What we will do here is to make it a little bit simple and to make it a little bit easier. we'll assume two scenarios. One is our system, and then eventually we'll compare with their calculation, their numbers, and then we'll understand the answer easily. So just for the simplicity purpose, let's assume that I have four coins of 1 rupees and six coins of 50 paise and eight coins of 25 paise, and they have given the rupees wala amount, mind you. So that is also very important. Now the thing here is, because they have given the rupees wala amount, so the suggestion is, do not compare the number of coins with the rupees, because every coin has a different denomination. So ideally you should compare rupees with rupees, because then that's a fair comparison on the same background. If you are comparing number of rupees with the, sorry, number of coins with the rupees, then in the end you'll also have to do some extra calculation. So, and that is the missing part which I was talking about. That is the blunder that normally happens, and you end up getting the wrong answer. So here, to avoid that, we'll simply not do that, and we'll compare rupees with rupees. So as we assumed, 1 rupee ke 4 coins, so we have 4 rupees. 50 paise ke 6 coins, so we have 3 rupees, and 25 paise ke 8 coins, so we have 2 rupees. If I add my amount 432, that means I have simply 9 rupees with me. Whereas they said that the chest contains 675 rupees. So my number is 9 and their equivalent number is 675. Yeah, our number is 9, their equivalent number is 675. So this means, what is the multiplying factor while going from our system to their system, for example? So simply that is 75. So from going from our system to their system, we have to multiply by 75. And then the question was asked, how many 50 paise coins are there? So if you remember, we had assumed that 50 paise coins are 6 coins with us that we have. But ours and theirs, the relation we have figured out, it is multiplication by 75. So we have assumed 6. If we want their equivalent number, we'll have to multiply by 75. So 6 into 75 gives you the right answer, which is 450 basically. Here what happens is, people end up getting the answer as 225, and that is also present in the option. But mind you, this is 225 rupees as an amount, and if I want to represent that in a 50 paise coins, obviously I'll have to double it up. Why? Because 250 paise coins gives me 1 rupees. I hope you remember that. It gives us 100 paise, which is 1 rupees. So to represent 225 rupees in a 50 paise coin, I'll have to double it up. So same answer. Mistake that happens is, people forget to do this multiplication in the end. So hence, I would recommend you also not do that. So compare rupees with rupees, number of coins with number of coins, and that makes the job much easier and much simpler, much cleaner, which avoids the errors basically. So that's the fourth question. Question number 5. The incomes of Yadav and Jadhav are in the ratio 4 is to 7. Their spendings are in the ratio 6 is to 11. Yadav saves one third of his income. Then the savings of Yadav and Jadhav are in dash ratio. Now see again here, the idea is, the ratio of incomes and spendings are given. From there we can find out the savings. So what we can do is, when we say the ratios are given, again it simply means that any any multiple of 4 and 7 will do the job, and any multiple of 6 and 11 will do the job basically. So point is, let's assume that their incomes are in the ratio 4x and 6 7x, because any multiple of 4 and 7, and their spendings are in the ratio 6y and 11y, because any multiple of 6 and 11 will do the job. Then their savings. Now simple formula, income minus spending will give us saving. So if we do that, what we get is the savings for Yadav is 4x minus 6y, and the savings for Jadav is 7x minus 11y. And now comes the important condition which they had said, that Yadav saves one third of his income. So his saving is something that we know, which is 4x minus 6y, and he saves one third of his income. His income was 4x for that matter. So we should be solving this equation now. So when we solve this equation, 3 goes on that side. So multiplies the whole bracket. We get 12x minus 18y is equal to 4x. This comes here, so this becomes 8x. This goes there, which becomes 18y. If I want to do x upon y, it should be 18 upon 8, which is 9 upon 4 is the ratio of x and y. And once I have this, I was supposed to find out their savings ka ratio. So their savings I also know. So for Yadav, it is 4 into 9 minus 6 into 4, which is 36 minus 24, which is 12. And for Jadav, it is 7 into 9 minus 11 into 4, which is 63 minus 44, which is 19 basically. So their saving ka ratio is 12 is to 19, which is none of the above as the answer options, for example. And that's how we can we can solve this particular question. I hope you have understood this particular question. Simple stuff, and we get the same answer. Now, let's look at the next one, the question number 6, which says the temperature of a country drops every time it rains, and the drop is directly proportional to the square root of the rainfall. Now, what is that supposed to mean? So, the temperature drop is directly proportional to square root of rainfall. When we apply this, and they have given the data also further, and that data is last Friday there was a 25 millimeter rainfall, resulting in the temperature drop from 32 degrees to 24.5 degrees. And they are saying that the present temperature is 24 and it is going to rain 16 millimeter. What should be the new temperature? The thing is, the relationship is given and the data is also given. So drop in the temperature is directly proportional to the square root of the rainfall. Drop in temperature directly proportional to square root of rainfall. They've given 32 डिग्री से टेम्परेचर ड्रॉप हो गया 24.5 पे. We'll have to subtract to find out the drop. and 25 millimeter बारिश हो गया. Now the present temperature is 24. What is the new temperature if it rains 16 millimeter? Again, I don't know that. I'm supposed to find that out. So let's suppose that is x now. So 24 minus x is directly proportional to 16 ka square root, because drop in temperature is directly proportional to square root of rainfall. Now, what we can do is we can simply divide both these equation, and let's start solving them. So 32 minus 24.5 is 7.5. This is 24 minus x. Root 25 is 5, root 16 is 4. If we multiply, this becomes 30 is equal to 24 5 is 120 minus 5x. 5x becomes 120 minus 30, which is 90. X becomes 18. So the current temperature has to be 18 degree, which is answer option 5 for that matter. So the values, the relationship, everything is mentioned in the data. All we have to do is simply read it carefully and find the answer to the relevant question that they are asking. Basically, that's what we are supposed to do. I hope you have understood this sixth question. Let's do the seventh one, which says similar kind of strategy. A railway engine can move at a speed of 28 kilometers when no wagons are attached to it. However, its speed reduces in direct proportion to the square root of the number of wagons attached to it. Very important. So speed is reducing in direct proportion to the square root of the number of wagons attached to it. So relationship is reduction in speed is directly proportional to square root of number of wagons attached. That's the relation. Now, the speed was 28 when no wagons was attached, and the speed is 8 kilometers when 25 wagons are attached. Speed has reduced by 20 kilometers, we can say. Now they are saying what will be the maximum number of wagons that can be attached. Now imagine this. If you want the number of wagons to be maximum, and since it is directly proportional to reduction in the speed, this should also be maximum because they both are directly proportional. So the speed is 28, the maximum speed is 28, but by which it should maximum reduce? So it can reduce by 28 only. And they're asking how many wagons we should attach in this case particularly. So again, same story. We can simply divide these equations. We get 20 upon 28 is equal to 5 upon root x. If you reduce this further, this becomes root x becomes 5 into 28 upon 20. So that means it is 140 divided by 20, which is 7. 140 divided by 20, which is 7. Now think about this. Root x is 7. So x should be 49, which is also present in the option. But hold on, you should not mark this as an answer. The only reason for that is some common sense that you need to understand in such type of questions. That is, now imagine if you attach 49 wagons, and that is the maximum number of wagons that you can attach, which is your answer also. The problem that happens is the current speed becomes 0 of the engine. That means the engine stops. Now, do you want that? Of course not, because you want best of both worlds now. You want maximum dabbas, maximum wagons that are supposed to be attached to the train engine, but you also do not want the train to stop. You want it to continue further. So to that happen, obviously we'll have to do something, and that means we'll have to reduce one wagon. So that means the correct answer cannot be 49, it has to be 48. Because if you remove one dabba, one wagon, the train starts moving some bit at least slowly and slowly, and it starts going further. It will not halt at one stop, it will not halt at one place. So that's the common sense. Mathematically speaking, answer is 49. Logically speaking, answer is 48, because if you attach 49 wagons, the train engine stops because the current speed becomes zero, which is something you do not want to happen. I hope you are getting this. So these are the type of questions, and this is the reason why they are tricky. You have to be very uh, present and openly thinking about them. Otherwise, you will make a mistake. Okay, let's do the next one. That is question number 8. The total cost of manufacturing 200 units of an article is 1700, while that of manufacturing 500 units of an article is 3500. If the cost of manufacturing, find the cost of manufacturing of 1000 units of the same article. Now, one key part here is the concept of fixed cost and variable cost, and the words are supposed to be total cost. So normally, if you are from commerce background, if I assume that, then you would have studied one concept, which is the concept of fixed cost and variable cost. So total cost is a combination of fixed cost and variable cost. Fixed cost is hidden, so normally we are not able to find that out. And we'll not get into all of these technicalities. We'll use a different approach, but yes, we'll play with the approach of variable cost. We'll think from that perspective. So simple perspective, more number of units you manufacture, more we have to pay. That means we can simply say additional cost is directly proportional to additional number of units. What we are going to do is we're going to play with that theme only as we discussed. So let's do that from 200 to 300. From 200 to 500 units, we will be manufacturing additionally 300 units. And to manufacture at those additional 300 units, we'll be paying 1800 extra. Now from 500 to 1000, you're gonna you're gonna manufacture additional 500 units. So first you need to find out how much is the uh, additional cost you're gonna pay out for that. How do we get that? So simple cross multiplication. If 300 is 1800, so 500 is how much? Suppose x. Let's do cross multiplication. So 500 into 1800 divided by 300 is the value of x. This is 5 6 are 3000. So x is 3000. That means for manufacturing 500 additional units, we'll have to pay 3000 extra, and 3000 extra for 500 units. But they are asking for 1000 units. So 1000 units, earlier we pay for 500, we paid 3500, and for next 500 we are paying 3000. So obviously the total cost becomes 6500 for the 1000 units. So remember this funda, folks. Additional cost is directly proportional to additional number of units only in the place of total cost wale questions. This concept we are supposed to apply when it comes to the calculation. So answer is 6500, which is answer option 4 for question number 8. Let's do the next one. This means a frog pursues a deer and takes 5 leaps for every 6 leaps of the deer. but the four leaps of the frog are equal to five leaps of the deer. Compare the speeds of the frog and the deer, basically. That is what we need to do. How do we do this? So, one important part here that we need to realize is that four leaps of frog are equal to five leaps of the deer. What is that supposed to mean? So we first things first, leaps can we say it as steps, and one also simple rule establishment. More steps is equal to more distance. Less steps is equal to less distance. Simple as that. And they are saying that four steps of the frog are equal to five steps of the deer. When that will happen, that means both of them are traveling the same distance. So what we should also be doing is we should be assuming something as the calculation. So let's assume that both of them are traveling 20 meters as the distance. And this 20 meters is covered by frog in four steps. This 20 meters is covered by deer in five steps, basically. So what we can find out is the distance per step. So frog is covering 20 meter in four steps. So frog will take 5 meter per step. And deer is covering 20 meter in 5 steps. So deer is doing 4 meter in one step, basically. You need to realize that. Now, earlier they said a frog pursues a deer and takes 5 leaps for every 6 leaps of the deer. The frog has taken 5 steps and deer has taken 6 steps. Now we know their distances per step. So, for example, frog is taking 5 meter per step and he is taking 5 such steps. So, obviously, he'll be doing 25 meter. Deer is doing 4 meter in one step and he's taking 6 such steps. So he'll be doing 24 meter. So what happens is we can find out the ratio of the distances. So frog is covering 25 meter, deer is covering 24 meter as a distance. So the ratio will also remain the same. But mind you, they are asking speed ka ratio. We know that speed and distance are directly proportional, which means the ratios will remain same. So whatever is the ratio of distance should remain the ratio of the speed also. So according to me, answer option 3 is the answer for the ninth question basically. And this is how we can figure that out. So folks, this is your ratio proportion. If you have any queries, do let us know. We'll be happy to help. Go through this again and try and solve all these questions all by yourself. Have a great day.